Okay, so here's example 2, and we're going to do this one now. So, oops. We have this. So again, we're going to just start with the basic. So this is just log. Always start with the basic and then your points. So this is x. So what you do here is I'm going to say we already know 1, 0. And we already know 2, 1. And we already know 4, 2. And how I can tell that it's this, again, just think about these. 2 to the 0 is equal to 1. You know, this is the exponent, right? The log will be the inverse of this. And that's the switching of x and y. 2 to the 1, that's just 2. That means 2 to the 2, well, that's just 4. Notice that the general statement here is 2 to the x, right? And we're just choosing, now x is all real numbers, but notice I'm choosing ones that we know, I already know the easiest ones. I'm making it simple. That's it. Why make my life more complex? That happens on its own. So this is one field where I can make life simple. I can constrain it. I can put a constraint on it and say, I'm going to choose to make this simple. So I'm just taking 0, natural numbers, 0, 1. So you know this is 2 to the x is equal to my y. Well, you know this is producing my xy point on an exponent. Well, notice the logs. It's just going to be, so this is my x, 0, 1, 1, 2, 2, 4. That's just points on an exponential that looks like this. That's your 2 to the x. That's all. The log is the inverse of this. So I know if it's 0, 1, it's going to be 1, 0, 2, 1, and then 4, 2. Done. Okay. So just have that. This is how I think about it, right? That's my thinking. And then I just have to remember, there's my formula. This is the key formula. This is not in the formula booklet, but you need to know how it works, right? So this is something when there's transformations, it always works like this. No matter what. If we're working with logs, exponentials, sine, cosine, whatever, you're pretty much doing this to it. So going back, I know that, and what we're looking at now is going to be, this is going to be, the second point is just log 2, and it's 2x. Well, this is a lead coefficient with the x, right? So I have to divide. That's working on the x. So it's 1 divided by 2, 0. This is going to be 1, 1. This is going to be 4 divided by 2. Well, that's just 2, 2. Now I have to do the last one. And the 4 is my y. So that's just adding to my y. So this is going to be log 2, 2x plus 4. So this is then just going to change 1 over 2 to 4. This is 1, and this is 4 plus 1, and that's 5. And then 2, and then add 4 to 2, which is just going to be 6. So there are my points. I can now sketch the graph. Yay. So there's my 3 points, and really I could just do it with 2. So I'm just going to use those to give myself an idea of how I can scale my sketch. Right, so this is my y. So then what I'm going to do here is it's going to be around 0 because notice there's no 0. The h here is 0. So it's our vertical asymptote is going to be, so vertical asymptote is y equals 0, x equals 0. Right, that's our equation, vertical asymptote. Then this will then be, what do I want here? So a half. So if I want 6, I can actually say that's maybe 1, 2, 3, 4. No, it's going to go up. So I only go, this is 1, 2. Am I going only, oh yes, maybe 1, 2. Actually, I'm going to make this 1, 2, 3, 4. This is my 1. 1, 2, 3, 4. This is my 2. And on the other scale, my y, I'm going to make this 1, 2, 3, 4, 4, 5, 6. Well, that's too high. So I'm going to have to do 2, 4. Oh, maybe that's what I'll do. 2, 4. Oops. 2, 4, and I guess 6. That's what I'll do. And then so if it's a half, so it's going to be right here, and it's at 4. So there's 1 point. So a half at 1 point. 1, it'll be 5. And then 2, it's got to be 6. So it's got to be up here. So I'm going to come up along here. And there you go. Right? So I could actually find, what is that point? I could actually find that point. Right? So that point is my, so if I have y equals log 2 2x plus 4, that's when y is 0. So this is 0. This is going to be then log 2 to the x plus 4. Well, this is just going to be minus 4 equals log 2 2x. Now to figure this out, it's going to be very small, notice. It's got to be, because this is a half. So we already know, and it's less than a quarter. So this needs to be less than a quarter, and we'll see that it should be. So how do I deal with this? I raise everything to the 2. So base 2, so we can get rid of, because remember, the princess is locked in the tower. Remember way back in September I talked about this? Princess is locked in the tower, prince or princess locked in the tower. I want to get them out. Well, I have to raise everything to the same base as the log. And that will come out. This you can then express as, this comes right down because it does not cancel. It's an inverse. So it automatically reproduces your argument. So it does not cancel. Remember, this is not canceling. Doesn't cancel. It's an inverse. That needs to be very clear. And then, sorry. And then this is just 2 to the minus 4. Well, then this is just x equals, remember, 2 to the 4 times, because I have to divide both sides by 2 again, I'm going to do, there we go. So x is therefore 1 over 2 to the 5. Well, that's a very small number. So you can already see that is going to be, so 2 to the, if 2 to the 3 is 8, then 2 to the 4, I think it's 16. Yep, 16. And so this is going to be equal to 1 over 32, I think. Just check that. See if my arithmetic is right. Right? So you know this is very small. So you know this that point here is got to be 1 over 32. Or you can just leave it as 1 over 2 to the 5 and 0. There you go. Done. Right? So that's your x-intercept. Okay? So I'll do the last example in another video. So make sure this is a technique that you have to, this is in particular a technique that you come back to time and again to know well. Right? You need to know this technique very well.